All right, welcome back to day 2 of conics. Today we are talking about circles and ellipses. So remember, we find conics by cutting planes into our cone 3D figure. So when we take the horizontal plane, that is how we get a circle. When we slant it a little bit, we get an ellipse, and those are the two we're focusing on today. Last time we looked at a parabola, which is where it's not quite vertical, it's still slanted a little bit, but more so than the ellipse. And then next time we're going to be looking at the last type, which is a hyperbola. And that is when we take the vertical plane through the cone. Okay? So, circles. Remember, a circle is all the points that are equidistant from some center. That center is HK, and that distance is our radius. So, the equation for a circle is x minus h squared plus y minus k squared equals the radius squared, where, like I just said, HK is our center, and R is the radius. So I'm not going to work every example through these notes because this video would be like 30 minutes long if I did. So I'm just going to do a couple from each kind so you see some different ways that we can write these equations with different sets of given information. So here on number 1, we have our center and our radius. So this is HK and that's R. So we are just going to plug those straight into our equation, and that's equal to 16. Okay. The next one. Number 3, we have center 1, negative 5, so again that's HK, and our radius is the square root of 10. So that's going to get us x minus 1 squared plus y plus 5 squared equals 10. Remember, when you square a square root, you get your radical cancels. All right, now what if you're given the graph? Again, we need two pieces of information. We need the center and we need the radius. So looking here, that dot in the middle identifies our center for us. So on number 5, our center is at -3, -4, so that's h and k. That should be a comma, not a minus. And our radius we can look at by counting. From the center to the edge, that is 2 units, so r is 2. And now we can plug all of those numbers into our equation. All right, now what happens if we don't have the information just given to us tied up with a bow, or we don't have a graph? Well, we are going to have to use some good old formulas that hopefully you are somewhat familiar with. That would be our distance formula, the difference in our x values added squared plus the difference in our y value squared under the radical, and then our midpoint, which is literally finding in between for your x and your y. So distance formula tells us the distance between 2 points on a graph, and our midpoint formula tells us the location of the midpoint between 2 points. So this is a distance, and this is a location on the graph. It's an ordered pair. It's coordinates. So, for example, if like on number 7, we're given the center and an end point, we know h and k here, but we still need the radius. So what we can do is we can find the distance between that center and that end point, because by definition, that is our radius. So let's do that. So the square root of x2 minus x1 squared plus y2 minus y1 squared underneath my radical. Again, with these types of problems, you're working from the inside out. That becomes plus plus. -4 plus 2 is -2. -2 squared is 4. 12 minus 6 is 6. 6 squared is 36. So this gets us the square root of 40. That is our radius. So HK, here's our radius. Plug it into your equation. And again, the square root of 40 squared is just going to give us 40. Now what happens if we're given the endpoints of the diameter? We need to find both the center and the radius. So first, let's find the midpoint between these two, because that is going to be the center of my circle. So -1 plus 5 over 2, 8 plus 6 over 2 is how I'm going to find that midpoint, which is the center of my circle. And for number 11, that is 2, 7. So there's h and k. Now I need to find the radius. You have two options here. You could use your distance formula on these two endpoints, and that's going to give you the diameter, and you would have to half that value. Or you can find the distance between this midpoint we just found and one of these endpoints. I'm going to go with 5, 6 just because I like positive numbers. And that is going to give us our radius, because from the midpoint to an endpoint, that's our radius. So x2 minus x1 squared plus y2 minus y1 squared, all inside of our radical. That's going to give me 3 squared, which is 9. That's going to give me 1 squared, which is 1. And so we end up with the square root of 10. So that's my radius. Here's h and k. Plug it into my formula. Not so bad, not so bad. Now, what if we are graphing circles? So again, when we're graphing circles and we're given the equation straight up, we just plot the center. So here on number 1, our center is going to be negative 2, 5. So I'm going to go ahead and graph that. And this is my radius squared, so my radius is 3. So from this center, I'm going to go up 3, down 3, to the left 3, and to the right 3. And then I'm going to do my best to connect those dots and make as best a circle as I can. Okay? So that's graphing circles, and that is it. Circles are pretty easy, straightforward, to the point. Ellipses, on the other hand, are a little trickier. So in an ellipse, we have some new information that we need to gather. What I've done is I've gone ahead and filled this stuff out, so I'm not taking as much time to write. So in an ellipse, this is like a circle that has been stretched either vertically or horizontally, so it's an elongated circle. And we have these 2 fixed points inside of our ellipse they're both called the focus, and the plural of that is foci. And what these focus do is they say that anywhere you're standing in your ellipse, the distance between the 2 foci, the sum of those 2 distances is the same. So we've got some new terminology we need to talk about. We have a major and a minor axis. The major axis is longer, the minor axis is shorter, and they intersect at the center of our ellipse. Then we have our vertices, which are at the endpoints of the major axis, and the co-vertices, which are at the endpoint of the shorter axis. And here are some labeled diagrams for both our horizontal and vertical ellipse. Again, in a horizontal ellipse, we have the center. The vertices are along that horizontal line, and the co-vertices are vertical. Then the foci are in between the center and the vertices. Same thing for a vertical ellipse, except it's stretched vertically. So we have our vertices, our co-vertices, and the foci are in between the center and both of those vertices. Now, we use letters to represent these different distances. So from the center to the vertex, that is A. From the center to the vertex. From the center to the co-vertex, that is B. And from the center to the foci, that is C. So the vertices are A away from the center, co-vertices are B away from the center, and the foci is C away from the center. And those 3 values are related in this way, which is not Pythagorean theorem. It's not plus, it's A squared minus B squared. Okay? And then here are the equations for a horizontal and vertical ellipse. A is always bigger than B. So when you're looking at where A squared and B squared are, A is always the larger one. So when it's larger underneath your X, it's horizontal. When it's larger underneath your Y, it's vertical. And this equation is always equal to 1. It's not like a circle where it changes based on the radius. We don't have a radius here. It's always going to be equal to 1. So let's graph some ellipses. Again, I'm just going to go through and do 1 for the sake of time. Let's look at number 3. I can identify my center from x plus 1, y minus 2. That means my center is at negative 1, 2. The number underneath the x is larger, which means this is going to be a horizontal ellipse. So the square root of 49 is 7, which means A is 7. The square root of 9 is 3, which means B is 3. So I'm going to go ahead and plot my center. And then to get my vertices, I'm going to go 7 to the left and 7 to the right from my center. Then to get my co-vertices, I'm going to go 3 up and 3 down. Then the best as you can, you are going to connect those 4 points to make your ellipse. Again, not going to be quite perfect. Going to do the best that you can. And here are the coordinates for all of those points we just plotted. Now we need to find the foci. So remember, c squared is equal to a squared minus b squared. Here's a squared, here's b squared. So 49 minus 9 is 40, which means that c is the square root of 40, which is about 6.3. So my foci are going to be 6.3 to the left and to the right of my center. And so those two coordinates are about there. Okay? All right, so that's the easier. When we're given the equation straight up, we just graph it. Now, how do we write the equation when we're given different information? Well, when we are given the graph, like we are on this page on number 3, we're told where the center is, right? We can identify it here. That is at the location 3, -6. And from looking at the graph, I know that this is a horizontal ellipse. So let's look at how far away my vertices are from the center. We can count 1, 2, 3, 4, 5. That means that A is 5. And from the center to the co-vertice, that's 1, meaning B is 1. And so looking here, we can fill in all this information about the vertices and co-vertices on our ellipse. I have my center HK, I have A and B. I can write the equation now. And remember, the bigger number needs to go underneath the X term because it is a horizontal ellipse. Now, because B is 1, I don't have to include anything underneath the Y term because anything divided by 1 is itself. Now, to find the foci, really quick, C squared is equal to A squared minus B squared. So that's going to be 25 minus 1, which is 24. So C is the square root of 24, which is like 4.9. So this one's going to be really, really, really close to the vertices. All right, so that's easier when we're given the graph itself. Well, what happens when we're not? Let's say we're given some vertices and the co-vertices, like on number 6 here. Well, these things help us find various pieces of information. Remember, the vertices, that's my major axis, so I can identify what A is by looking between -5 and 1. That's what changed here. My Y values didn't change, my X values changed, and if those are along my vertices, that means that this is a horizontal ellipse. So from -5 to 1, that is 6 apart. Half of that is my value of A, so that means that A is 3. Then on my co-vertices, the Y value is changing. From 3 to -1, that's 4 apart. Half of that is 2. And if you can't do that in your head, you can absolutely use the distance formula. Now I just need to find my center. So let's use our midpoint formula. You can use any of these because they will give you the same answer. So you could use either the vertices or the co-vertices to find that your midpoint on number 6 is -2, 1. So here's H and K, here's A and B, it's horizontal, so the bigger number needs to go under the X term. Oh, that should be 4, not 9. Equals 1. All right, and then one last scenario I'm going to run by you is when you are given the co-vertices and the foci. So let's look at 10. I've got my co-vertices, meaning that this is going to be my B value. So from 5 to -5, because that's what's changing, those are 10 apart. Half of that is 5, so B is 5. Okay, I can also go ahead and find my midpoint, which is going to be my center. And this center is actually at the origin, 0, 0. So I still need to find A. Now, if I'm given my foci, I can use that information to find C. So these foci, from 12 to -12, that's 24 apart. Half of that is 12. So C is 12, so I can use C squared is equal to A squared minus B squared to solve for A. So that 12 squared is 144. I don't know what A squared is, and I know that's 25. So A squared is going to be 169, meaning that A is 13. So here I have H and K. They're both 0, so I'm just going to have X squared and Y squared. Here's B, here's A. Now, is this a horizontal or vertical ellipse? Well, my co-vertices are in the X direction, which means my vertices are in the Y direction, so it is a vertical ellipse. So we're going to have X squared over 25 plus Y squared over 169 equal to 1. And that is each different type of problem that you're going to see on your homework and possibly on a test when graphing and writing equations for circles and ellipses.